between the indoor conditioned space and the below grade ground temperature. So again, if you insulate the crawl space and bring it inside, and you the temperature of the ground is 0 at the top and 40 at the bottom, that's a lower temperature difference between the indoors and the outdoors than if it's all above grade and it's 10 degrees outside, 10 below outside and 70 inside. So you're fighting you can deal with lower R values, effective R values here, and still have it be effective. And the air barrier, doing a complete air barrier underground is a little easier in a lot of cases than doing it above grade. If you, and this is just a comment again about you can keep the foundation warm, you have less likelihood to have frost action, where you'll have heaves in the slab or in the wall. And the foundation wall problem is generally more in rubble walls than it is in poured concrete walls. So they're a little more prone to frost action. We'll talk about that as we go. So you're going to protect the structure against damage if you keep the crawl space and basement dry. Reduce the likelihood of attracting vermin and bugs if you have a good airtight crawl space or basement. And you're going to protect against indoor air quality problems due to mold and mildew and so forth. Probably you can, if this space, if it's subject to radon and you're putting the building envelope down below, you probably have half of your radon system already in that enclosure compared to if you're trying to do it. Of course, if you're up on stilts, you're not exposed to the radon anyway, but it's radon is a problem you have to deal with. And I'm going to show you slides of some buildings with radon issues. So gain important space for living. So you can put your laundry there, your hot water heater, your central heating system. It will usually increase the property value and save on overall construction costs because you have some place to put the mechanical equipment. It's either the crawl space or the attic. If you're down south, it might be neither, but for some reason, they always put the mechanical systems in the attics where it's 180 degrees. But I don't know what to say about that. But so here you get you keep the water line inside the conditioned space, so you get it in the ground, which is 40 degrees because you're below grade. It might be 45 depending on the climate zone. Okay, bulk water. You have liquid water, solid water, and vapor. Bulk water is the liquid piece of it that we're going to talk about that first. So you have surface water and groundwater to contend with. So you want to manage, does the water get in? So your first goal is to keep it out. Ideally, you're going to put drainage outside the foundation, but that's not always easy given a retrofit type of situation. If you put an impermeable surface treatment, anybody doesn't know what that is? Basically, you're going to pave the outside in a way that it runs the water off so it doesn't run down the ground and go in through the foundation itself. Conduct the water down to a level below the basement floor, which is what we typically do with our standard foundation drainage systems, and reduce snow water near the foundation. And that's a gutter type system. And you have to prevent moats from snow slides and landscape. So if you have a metal roof and the snow slides off the roof and builds a little mountain around the house, 2 feet out from the wall, but that's how wide your soffit is. then as the snow melts and as the rain comes off the roof, it's gonna run down into that moat. And then as the ground, because the ground is warmer, it's gonna run down in the ground and through the foundation. Okay, so keeping it out as much as possible, that's the first goal. Here you can see, this is a seasonal water. I'm gonna talk about seasonal high groundwater levels. And that's the level up to which you need to provide your drainage. So if you're gonna put in a drainage system that carries the water that comes in through the foundation by diffusion or by bulk water transfer, you want to run that drainage system up the wall so you're above the seasonal high water. And these are just some examples of that. Of course, the window well is often on my house. I have window wells that are full of ice in the spring. And fortunately, they're sealed from the crawl space, so they don't leak, but they could. So this is examples of, here you can see the seasonal high water level is halfway up the duct. So the question is this duct sealed well enough that the water is ingressing into the ductwork, and then you have mold mildew and other problems inside the duct. Sorry. I was piping up time. Okay, so groundwater in through the foundation. This is the building science drawing. And this is more by diffusion, although you could have if you don't have a good water stop at this joint, the water can come in and get up onto the slab. And we'll talk about water stopping. This is that moat around the house where you have a pile of snow that fell off the roof. You got the water up to around the building in that moat. It's a bathtub, it's a swimming pool. And that water can run down eventually as the ground warms up. It melts the snow and ice, and you have this. And this picture right here, see this little gap? If you pour a slab in a basement, hold it away from the bottom of the stone wall so you could have a gutter if you needed to go to a pump. Or if you're lucky and it's a walkout, you can go to daylight from some kind of gutter system. But give yourself a way to get the water out of the basin. That's wrong. This is a complex. This is the foundation under this building. We're going to talk about keeping the water out. So they have a bathtub around the outside of the wall that's just got stone in it. So the water can run down through it. Around that, it's paved with brick, which is not grouted together. So all of this is water permeable. And the water used to run in here. And the groundwater in here was sometimes several inches inside the crawl space. This is the building that's right in the brook, right outside of Boston, actually. And all the landscapers go around and they dig out all the dirt, everything that might be relatively impermeable. They fill it with chips, which is very permeable. And they put these little short pieces of downspout projections that run the water right into the bathtub. And this water all runs down and into the crawl space. So you want to extend those if you can beyond the bathtub, but ideally you don't want to create the bathtubs in the first place. So here's an example of a dry well. This is the footing drains going to daylight. This is a foundation wall that has been pushed by frost action. And there are different building science discussions about whether frost action is even possible. But my goal is always not to make this problem worse if it doesn't. It takes this. We want to keep this foundation warm. if we can, where it's below grade. So I'm gonna talk about ways to do that. This was a job that we did that was a guaranteed, not gonna push by the engineer. And he had us run the foam all the way down. My preference is to run the foam to just below grade. And then extend the drainage plane and the air barrier with a membrane that doesn't have a lot of R value. So the foundation down here at the bottom stays warm. From heating the house. From heating the house, yes. So if the basement is normally 60. And from a foot below grade down to the bottom is just a sheet of membrane. Keeps the moisture out, you don't have evaporation of water coming through the stone wall into the living space. And you don't have, and then the water running down behind the membrane can go into a gutter.
Why do you prefer that?
Because if you freeze the foundation, you can have frost active.
Like better is inside the wall or is it outside the wall?
This doesn't have one.
Or it's worse out.
The structural engineer guaranteed that this would never leak. And I'm here to tell you, we had a callback because the water leaks.
Oh, I definitely will.
Into the foundation. I had to have it in writing.
Henri, my question is, you spray the top 3-4 feet of foundation wall, you're getting the below frost level.
No,
At 3-4 feet of the stone.
no, this only goes to a foot, or this one doesn't, but I'll show you some too.
So how far would you recommend the foam going down a rubble foundation wall?
1 foot below grade.
1 foot below grade. Okay, so you're leaving the frost is able to get into that wall from the outside. Well, you're not protecting the wall.
The heat that goes into the wall from there down
Yes.
will also
You're trying to get
migrate
Yeah,
enough up to keep
understood.
the stone, the rubble wall.
The 1 foot below grade.
Yep,
So are you advocating for 15 mil poly coming across the slab and up the walls and?
reinforced, UV
With that.
stabilized. We always use the product called True Tough. I don't know if it still exists.
Stego wrap.
Yes, something that won't won't degrade due to ultraviolet. And I'm here to tell you there is ultraviolet in crawl spaces even. Certainly there is ultraviolet in basements. Usually reinforced 20 mil, 16 mil, some heavier gauge than 6 mil poly. And I'll show you some pictures of this. It works. I've done, if not thousands, I've done hundreds of rubble walls. And we'll show more of those as we go. This is a particular building. This building had the entire basement, crawl space is ledge, exposed ledge. It also has radon. So this is a double whammy. They also built a stone wall around this to create a real moat in this case. So here's the stone foundation, here's the brick floor, here's the stone wall that keeps all the water in here, so you can't have drainage. And there are no outlets for this water that comes off the roof and into this patio. Here's an example of some fixes for that. You can put in trench drains that don't look bad. And you can even have them in the driveway where you can drive across. So you want to provide a way for the water to get it out. And I'm here to tell you, you can't do everything in all of the make the grade impermeable. You'll never guarantee that all the water, no water will ever get into the foundation. You're going to assume it's always going to get into the basement. So you want to provide capacity for drainage in the basement that is capacity for the maximum seasonal flow rate. Want to isolate the flow flow path from the conditioned space, so you don't have evaporation into the basin or crawl space. And you want to run the poly that you put on the crawl space floor or basement floor up the wall far enough to be above the ingress level of the seasonal high water tables. And I have done floating membranes. They're very difficult to implement. And a floating membrane, conceptually, if you think about it, you got a, let's say you have a crawl space or a basement that has 2 feet of water. Okay. And you fill it with ping pong balls and put a vapor retarder on top of the ping pong balls. That's a floating membrane. And they're very difficult to manage. You can't see if you can drain it, you want to drain it, that's a better solution. But if you're below the brook or the river or whatever with your basement, you have to either put in a floating membrane, drain it, or you can raise the floor to above the seasonal high water level. I'm going to show you a picture of a application with it.
It's got highly technical thermal question.
Yes.
Does anyone in the room know why they propped the doorway up?
No, all that.
And you go with that door too, that.
It's making a pressure in it, and that's what's possible.
I don't, people are getting cold, I don't know.
And if she comes back in, it's like, I have it.
We'll tell her you did it, man.
Yeah.
We'll tell her your fault.
I'm in charge.
There you
Building science, Joe.
Yeah, bunch of building science stuff.
Now the door-
Tail switch, and we don't need a door.
Now that door will stay closed. I mean, good.
Okay, so this is this building with ledge everywhere in the basement. And there are places in this ledge that are what I call a perch, where the water is a pool. So the water's coming in through the foundation, but it can't run over to the low point in the basement because the ledge is mountain. It's a mountain range and it's in the valley between the mountains. So this, we had to put in a sump pump in every one of those pools. So there's several of them here. And we ran the pipes from the sump pumps down the valleys. Here's one in the valley. To the sump in the bottom of the foundation. Yes.
Yeah, so we ran a bunch of ledge in different projects that we've done, and we played with the idea of spray foaming them directly onto the ledge. We have not had a problem with that yet. Have you seen failures to
We
spray
sprayed this
foaming?
entirely.
And
I have not seen a failure with
I mean,
that.
if there's enough water pressure, it could potentially, break the foam or break the bond, but you haven't seen failure on that, no.
Well, your sump pumps would all have to fail.
In this case, there was no sump pump, but there's no divots. It was just trying to keep the water pipe out through the ledge.
And redirecting it. So I had the same situation.
Okay,
Chester. Ledge was off.
yeah. It's a little different here. We're talking about divots. I haven't necessarily addressed that with trying to do it with foam, and I would imagine the sump pump would be a good solution.
Well, I'm gonna show you the foam. So here's the drainage plane on the walls. And this is 2-ton. And it's a poly vapor retarder. I think it's 16 mil. And here are the drains going, the sump is down here. So we're running all the water down there. And this is, we laid poly over those pipes. So that if you ever needed to access those pipes to repair them or replace them, they wouldn't be encapsulated in the spray foam. And when you do the thumb test on the foam on the ground, you can tell where these are because they sound hollow. But you also have spray paint on the top of the spray foam showing you where they are, so you haven't lost them. So here's the spray foam covering the lid. And these are indicate where all the drains are. And there's the pump. So always assume the water will get in. Strategies for new slabs, always put stone under the slab and run it to daylight. Can't run it to daylight, run it to a sump. Existing slabs, you can either pour a new slab, a thin slab on top, a scratch slab, and keep the gutter around the outside edge. Or you can seal the slab and put a parapet around the edge of the slab so that the water can't get into the area, the walking area of the floor. So the Abbott and Joe's basement, I'm going to show you Joe Seaworth's basement, which
We can see Joe's Seaworth's basement.
got right.
Oh,
You don't have to.
that's nice. Yeah.
I'll slip it.
Yeah.
I thought it would be a good example of something that you might like to see, but if you don't, I know, I can skip something. Okay, this is hybrid foundation insulation retrofits. This is Joe's basement. And this is bulletproof Joe's basement, obviously. He's using ice and water shield in this case instead of too tough for some less expensive membrane. And Joe jacked up his house about that far and put a diffusion barrier between the foundation and the sill. So if you want to talk about going to the extreme, that's the next one.
He put in seal, like the.
No, he put in, I think they put in copper.
So a
Vapor barrier.
something that, yeah.
The basement is still running.
Well, it's diffusing from the concrete or the stone up into the wood.
Very talking about.
That's
what's happening.
Yes. It's a barrier, but anti-barrier, then it's not stopping. Okay, this is an example on the outside of a way to drain a foundation. And this is below the level of the concrete slab inside, which should be 4 feet above the footer. 4 inches, sorry. Here's some examples of retrofit gutters. This requires cutting a trench in the concrete. This is another cut the trench in the concrete solution. This is one that's applied on top of the foundation. These are under the slab, sorry. And this is the water is running down the inside and to the drain.
Is that drain pipe, is it perforated all along the way, or is it made single collection?
This one?
Yeah.
That's perforated, because you want to let the water in.
Right. All on the window.
Exactly. And ideally, it's pitched to the lowest point in the house. So it can go to daylight or to a sump or to a dry well. This is more of Joe's house. Here's his trench around the outside. Here's another retrofit. You still have to cut the concrete here, but this lets the water in. This one is a retrofit on top of the slab, and they're relying on sealant to make this a watertight assembly. The water can run down the wall or through the wall and be inside this baseboard gutter. But it's eventually going to go leak out into the either floor drain or sump.
With the floor drain like that one, how do you prevent pulling outside air through the border.
You put in a
It's,
trap.
you put a trap, like a water trap?
Yeah.
What if the water trap dries out?
Yeah.
Yeah.
See, it should fill every year.
It should, you know, if you have a wet basement, but if you end up not having a lot of water filtration going through it, then it could dry up.
Exactly. So in these scenarios where they're working on the inside of the foundation, like with insulating and waterproofing, is that because it's easier than excavating the outside and doing the outside, or is it actually better?
It's usually less expensive and mom doesn't want her roses dug up.
Right, okay. But if you could do it on the outside,
It would be better problem.
You wanna always prevent it from coming in the first place instead of having to remediate it, getting
Yeah.
there. Yes,
good question, and that applies to the insulation as well as the waterproofing. Insulation on the outside.
there, I'd say that. Where's the insulation in your wall up in the first floor?
Oh, whether it's inside or out.
You wanna meet those two if you can.
Right.
And one of the problems with exterior insulation and foundation, one is burning and ants. The other is how do you connect the outside insulation to the inside insulation when you get to the. So.
Well, today's codes are continuous insulation on the outside of the building, so that those planes will come down.
Perfect.
But you still be protected, you
Right, yeah.
protect, but damage from rewet, yeah.
You don't see that in the retrofit. No. Okay. So this is the create a gutter by pouring a new slab. And a lot of these rubble stone foundations don't have a poured slab. They're just dirt floor or hopefully it doesn't. So if you're gonna pour a slab, create the gutter. And one thing I learned, we would run the membrane down the wall and over onto the slab. The water would run down the back of the membrane on top of the slab and sealant didn't always work. So you want to always put what I call a drip leg. You want this to go down below the top of the slab and then up onto where your sealant is. So that's an important detail if you're creating a gutter.
That's just a membrane.
Pardon me?
That's a membrane.
The heavy black line here is the membrane.
Sorry, where's the drip leg?
The drip leg is the part of this membrane coming down below the level of the floor because the water can't run uphill. So it'll run down to this point and drip off into the gutter.
With these gutters, do they, if you're pouring a new slab in an old dirt floor, do they need to be pitched somehow? Is that complicated to achieve?
If you're planning, like, if you have the washing machine running onto the floor, yes. Once the pitch is the drain. If your basement is dry, you're perfectly level and have wall-to-wall carpet on it. So, this depends on how well you can dry out the basement or the problem. Be sure that you're not gonna have mold that are ruin the floor.
The diffusion point, if diffusion separation from the slab.
Yeah, and I'll show you a cheap way to determine. Just get to it. Here it is. Okay, so here's your do-it-yourself test for that. You take a garbage bag, lay it on the concrete floor in your basement. And that, it's dry and dusty and you'd say there's no water coming out of that slab at all. So you lay a garbage bag on it and you go down the next day and take the bag, lift up the bag and there it is. That's how much water is coming through the slab that you didn't know was there. So this is a bag, what I call a bag test or a vapor source calorimeter test that you can do yourself with a garbage bag. And you can do this on the wall too. Just take it on the wall and if it gets wet behind it.
So if you have that amount of vapor in your basement, you need to pitch those gutters.
No, you paint the floor with a vapor retardant paint. Paint the concrete. Because this is not bulk water, this is water's coming. And this is a 50-year-old slab, this is not new concrete that's still hydrating, it's new. It's had plenty of time to dry out here. Where? Okay, we're doing this. All right, so we've got bottom line. Anything that can't be drained to the sewer or daylight, you're gonna have to use a sump pump. Okay. Make sure you do this with have an electrician do this, because this is where you can have electrical problems. And make sure you monitor and make sure your sump will always work. Ideally, you would have an alarm on if you have a significant amount of water coming in, you want to have an alarm on that system, and you can do that with a float. Some examples of some well-designed and implemented sumps. Again, when you have this kind of prevention of keeping the water from coming in, you're probably going to need that. These are examples of crawl spaces that I did 100 years ago, but this is above the seasonal high water table, and plastic goes up maybe to foot below the top of the stone, because the grade is right there. So the plastic goes up behind the spray foam. The spray foam starts at the other side of the floor and goes down onto the vapor retarder.
You run into issues with that plastic running behind the foam and not getting the adhesion to the foundation.
That's why we pick too tough, because the foam will bond to it. Yeah. If you use plain old poly, it won't stick. Or if you crawl around on there and pull the plastic at all, it'll delaminate. And then you lose your seal. It's a great question. And you want to pick a product that the foam will bond to, and if you're not sure, take a kit and spray it on some of the plastic you're thinking about using, make sure it doesn't debond.
In the too tough, do you have to mechanically fasten it, or you just roll it up?
We use, if you do gardening, they make U-shaped fasteners to hold your landscape fabric down. Staples. Yeah, and that's what we used. We held it down to keep it in place while we moved around on top of it. And if you have a low spot, poke a hole.
Yes.
Assuming what's under it is going to absorb the water. If what's under it is ledge, then you want it to run down on top and then get to a hole at the sump.
There's a lot of opinions on whether that should be taped or not taped. What is your opinion?
Make it all one piece.
Tape, well, yeah, but I mean, if you overlap it by a foot or 2 feet, what's the importance of taping that seam?
We sprayed it. Because we were there with the gun insulated.
Okay, so you spray your seams. So what's the importance of it? What's causing that vapor drive to squeeze in between the 2 layers of poly?
It would have to be air transport, I would think, not diffusion.
Me too. So typically it wouldn't necessarily, doesn't need to be saved. It's kind of like a Band-Aid. Yeah, it's suspenders. Yeah,
Exactly.
doesn't really need to be done. It's kind of more of a look good kind of.
It's more of an air seal issue than a.
But when you below grade, you don't have an air seal problem.
Well,
That's
not always.
You've all got the radon gas.
Yeah,
Yeah.
there's
A little bit of rate.
The other thing is, if you ever done a blower door test or a theatrical depressurized fog test in a crawl space, make sure you do a pressure test on the depressurization test, because it'll lift all that stuff up and tear all the seams.
Oh, God.
It's good if they were getting, if it's a really tight crawl space where air infiltration could get through the
From
raw
the
foundation.
outside,
Yeah,
through the stone, or
yeah, but if you're below grade,
but it only has to get through at the top.
Yeah.
Yeah, and it'll inflate that And,
So if you use a rain screen and do all of that, then yeah, you're likely to be pulling out.
right, so we always put the fog machine inside the crawl space, pressurized it, went around the outside and found out where the leaks were. And then air sealed it that from, with that perspective. But, number one, if you do a depressurization test with fog outside. And it gets into the crawl space, you can't clear it. So you can't seal the joint and then do another fog test because the crawl space is full of fog.
Don't do that way.
Now, this is an example, this is again where the brook is, that's the level of the brook. And, when we opened the trap door and looked down in the crawl space, you can see a concrete block under the water level, but there was about 2 feet of, I don't know, 14 inches of water in this crawl space. Oh, 18 inches, there it is. Okay, so, curtain drains didn't work, footing drains didn't work, we would have to use a sump pump. Or raise the floor level or use a floating vapor barrier. And in this case. We chose to use the raise the floor level above the seasonal high water.
Can you explain a floating vapor barrier?
Ping pong balls with the retarder on top.
You put ping pong balls on the bottom.
The top,
So you just,
right? You're just talking about take plastic across the whole.
well, you know, you're talking about putting a whole
No.
lot of little floating plastic balls underneath there.
But they're 4-inch size.
Yeah, like the ones you go to McDonald's, you used to go to the playhouse, right? Like those.
They are like that, and I'll tell you, they use those in out west to keep reservoirs from losing all their money, all their water by evaporation.
Interesting. So the installers are waiting in the water, float the balls down, bring it in.
Right.
That flow will go down.
Gotta figure out how to take these things.
Yeah, in the midsummer, balls are just laying on the ground. But the plastic and the slack is around the edge.
Yeah.
But in the spring, those things are floating when the vapor.
Does the membrane differ in terms of product from what you would do? So how would the flow?
Yeah, I
will
would
be
use,
additional video.
yeah, I would use a product that is designed like for a landfill liner or something that
Yeah.
they can aggressive
In that scenario,
environment.
sure as hell better take it, right?
Yeah.
Not what you want.
Well, I would
If you can get the tape, if you can keep the plastic dry enough to tape,
Right,
while you're waiting in the water.
yeah.
Yeah, I would think you would have to seal the joints like you would a rubber roof with
Yeah.
heat.
Yeah.
Flexible. I've never done a floating vapor retarder because I never thought it was really doable.
It'd be a hard thing to figure out how to do, yeah.
Yeah.
It's fun.
This particular job, we actually hired the local concrete ready mix contract people to, we pumped it out. And the plastic was there. And there was plastic under that 18 inches of water. And we had the ready mix people come and bring a fly ash slurry. And we pumped that into the crawl spaces and raised the level, the finished level of the floor in the crawl spaces.
Go above that water height.
Here it is as it's going in, here it is as it's being level. And here's the finished crawl space.
So fly ash has got the cheapest concrete you can get.
We just wanted fill.
Volume. Yeah.
Fill that we could pump.
Yeah.
And this was very successful. I told them. If we run the tests on this and the humidity's still high. We'll put a sealer on the concrete, but we didn't have to do it. So, but we tested all these crawl spaces for humidity and.
What's your threshold on the humidity in spaces?
I would say 60%, 70%. Well, I mean, the recommended healthy relative humidity for buildings is 40 to 60.
Yeah.
So that's just at the top of the healthy range.
I think code is said that
too high in the winter.
I'm just telling you what the health industry says.
Yeah.
Means like,
Might apply more in rebuilds if you're completely sealing it, but do you ever worry about creating such a sealed volume under the water level that the water pressure basically tries to fill up the house up? Is that?
it's just a membrane, it's not gonna lift the house, it just lifts the membrane.
But in that case, where
Oh,
you're
with
making it
the
rigid, but
concrete?
the concrete, or in a new build where you have a.
It's definitely not strong enough concrete to do that. This is a fly ash slurry, which is. You know, it wouldn't be in that, you would never pour a slab like that for,
It's heavier than the water, you know, that would
Yeah.
sink, if you put it in water, it'd sink the bottom.
so this.
The water
this is
table would
not
have to.
Not gonna be as strong.
Right.
Do that fly ash to concrete structural that turn the concrete into non-permeable material. Makes it the most expensive. Volcanic gas, I think it's stuff it again, 50% fly ash.
And fortunately,
It's radioactive.
Yeah.
the ready mix company we worked with do a lot about what you're talking
How
about,
many cubic yards in there?
Hmm?
How many cubic yards?
a lot,
Yeah.
but it was cheaper than all of the other alternatives, so we did a return on investment on it. And this is what we came up with as the, I mean, these houses were a mess. And they were gonna lose them as rental space or for sale space. So,
Something heavy.
yeah, it had to be done. This is the relative humidity in those crawl spaces. And it was 64 outside, 64 outside here too. So the relative humidity in the living room was 65, in the crawl space it was 51. The indoor humidity in the crawl space was 89 prior to the retrofit. It was 50 after the retrofit. So you can see here the difference.
When the dates are the identical, then. So how could they be?
Yes, we were working on 90 units.
Got it.
And those tests were the same day, that's why these were the same. So, and then here's another unit, this is a 5-foot crawl space, so again, here we're. Indoor temperature was 45, this was in October. And it was 60 inside, these were unconditioned crawl space. So this was strictly ground source heat and through the floor heat loss into the crawl space. So that's no insulation on the bottom. R21 on the walls. And the floor was just subfloor, just plywood. So capillary action is wicking up to the concrete or the wood as in a sponge or paper towel. Powerful force can move large quantities of water. This is an example of how you test for that. That we talked about already. Evaporation of unmanaged bulk water ingress. So if you have a brook running under your house in a confined crawl space, it's going to raise the humidity by evaporation. So you can also have plumbing leaks, clothes dryers not vented to the outside, and mechanical system product of combustion. So these kinds of projects where you run not only on the floor of the crawl space or basement, but up the columns would prevent that kind of wicking up into the structure. And these are masonry, not wood. If those were wood, they'd be dead. More examples of that. Now, this is a factory scene, not a site built scene. So this is an example of the before and after. So you protect the vapor barrier. And on top of this vapor retarder, we put down, somebody in this particular project wanted gravel instead. So instead of pouring a slab, they have gravel. It's vapor. So this is the big problem I see all the time is air coming in through concrete block walls. Because the sill is always 6 inches wide and the block is always 8. So you always have this net opening. And this is, I mean, depending on which side the mason was on, this I often joints are not tight in these blocks on both sides. So when you insulate the foundation, you want to come across over to the sill and seal to the rim joist and up to the floor, not just to the top of the block wall. I see that all the time. You know, you could reach up, a lot of times in basement, if you reach up over the top, you can feel, you stick your fingers down in the blocks. You know, and there's foam on the rim joist and foam on the wall, but nothing on the horizontal, because they couldn't get to it.
Hard to get.
They would have needed.
You gotta twist the
They would have needed a step ladder.
That's not easy. It's much easier to go like this.
So, seal the rim joist, seal the other transitions. Now, this slide, we did a lot of condo units where there were party walls. I didn't know what a party wall is, right? Okay. These basements and crawl spaces were open to the party walls right up into the attics.
What's a party wall?
2 units.
It's a separation wall between either two units or two buildings that are right against each other. And that space usually is drywall on both sides, or if you're lucky, it's 2 stud walls with drywall on both sides and a space in between for sound separation. But that's always a great chimney.
Did it get its name from like party line where you could hear?
I don't know well, you probably could hear it, but
It's a shortening of partition.
Oh, thank you.
It's not that much.
That makes a lot more
Huge
sense.
fire.
Yeah, you have to have blocks, fire blocking requirements for it. And certainly,
So it's not like bullet
Yeah.
frame, sorry.
right, this problem is definitely a fire code issue.
Yeah.
And we did a lot of condo work that, you know, the fire department would tell us, you guys are saving these buildings because, you know, we were stopping fires from spreading not only up between the units, but then through the attics from units.
Kimbo a few years back had like 3 major fires. It's I think they were a year, but they took out 8 at a time. And then we got with hot blocks and just sort of where it got.
Exactly, I understand. So this is an example of what a party wall might look like. And this could be 2 separate units, or it could be a plumbing chase in a single family dwelling. You want to seal these off at the basement or crawl space level, so they're not open into the attic, or if you're insulating the attic, don't seal it up there. One end or the other will stop the flow. Okay, insulation protect pipes in the foundation from frost action, saves energy. Here's an example. Some people can't decide if they want to close up their windows in a basement or crawl space. Here's a retrofit for that. So we would wrap a sheet of rigid foam board in plastic, put it in the hole with the ends of the plastic all bunched up like a garbage bag on the inside. And then we would spray it. And on the right, you can see he grabbed that bundle of plastic that's in the middle right there. And he popped it out because foam doesn't stick to polyethylene. It'll make a reasonable seal until you break, until you pop it, and then it breaks. So that lets you decide later you wanna get the daylight back or ventilation. And you can remove that insulation.
You're saying that closed cell circle doesn't attach to forward,
It doesn't what?
attach to forward?
It's got plastic on it.
Oh,
doesn't-
that's, oh,
it's-
okay.
Yeah, we wrapped the board with polyethylene, 6
Okay.
poly,
Okay, gotcha.
and bundled it all up here, and you can see, so we could grab it. And then I had the guys ruin one of their, one of their installations, but this was after the job, we popped it out to show that we could.
Yeah, it's that easy, huh? It just really pops right that up? It's not that hard to pop up?
He did it,
And you could essentially pop that back in. You wanna, you know what I'm saying?
yeah, or you could cut the back of it, which would essentially break the
Yeah.
foam board, and you get it out in pieces. But you can get the window back without having, I mean, if you sprayed that right on the window, you'd destroy the window.
Yeah.
So. Just some pictures of some pretty spray foam to a foot below grade.
What, you have an estimate on like the energy use difference spraying the entire foundation wall versus maybe the couple feet to then keep it warm? Are you-
Well, I think this tells the story. Right here. So here's a crawl space that's 51 degrees when it's what's the outdoor temperature?
It's the next slide that has it.
No, it's right there. It's the next one up. Outdoor, oh no, that's outdoor. You're right, the next side.
That one has the
Outdoor
outdoor
temperature
temperature.
34, okay. So when it's 34, it's 60 inside without any intentional heat. And whereas without the insulation and the air barrier, it would be 45 in the crawl space.
That doesn't really say how much he's leaving.
No, but it's a sense that you're only 2 degrees different than the living room. So you don't have a big loss through the crawl space, it's all below grade. And where it isn't below grade, it's insulated. So that's why a foot below, from the bottom of the subfloor down to a foot below grade, always worked out to be the best return on the investment.
That's for.
That's the question, like, why, how much value is it insulating deeply below ground? That, like, below that.
You can calculate that, but what I'm saying is it never was enough to make it worth risking the foundation.
Okay.
But
Rubble.
you recommended that for a rubble foundation, you also recommended for construction foundation.
Sure.
Say that more convincingly.
Pardon?
Say sure more convincingly,
Well,
because that's a really, I have the same question.
my problem is, do you want to be responsible for a foundation that is cracking and collapsing?
Oh, you're supposed to.
I can hear you.
Does that relationship change when you wrap plastic of it? And you're preventing drying the interior and you're also,
You mean from poured concrete?
yeah,
No, it's gonna dry to the outside. Because you don't, if you're doing the inside, you don't have insulation on the outside.
yeah.
Right. And if it, even if you have a tar coating on the outside, number one, that's not perfect. Number two, it's still wick up through the concrete till it's above grade and diffuse to the outside. But when I didn't differentiate between stone, rubble and poured concrete simply because, I was making such an improvement in I've done floor door tests on these wall spaces. And the numbers were so big that that was the benefit in my opinion.
Yeah.
Like I was telling you about, when we inject a wall and the cavity is only 3/4 of an inch thick. you're not getting much R value.
Negligible in terms of insulation,
But when you seal around all the way around every punch out opening,
yeah,
suddenly it's a big return on investment.
yeah.
I would think it'd be really hard to do energy calculation of the difference between going all the way to the floor or just to flipping at different stages.
You'd have to do it
down and then like here.
No.
Test and then
calculate it on the R value.
But the gradient's constantly changing throughout the whole.
Just take the average, take the midpoint,
Well, you have to do it.
integrate it, you get the same result.
Wait a
It's
year,
not that hard.
you do your test several times a year and then wait a whole year, then spray the rest of it, and then the next year you do all the tests again.
We did a job for Building Science Corp. And they did all these calculations. And we did what I call the Abbott system, air vapor insulation and drainage system with the vapor retarder from 1 foot below grade down. And the foam from there up. And Building Science had like 10 different contractors with 10 different systems do this, the foundations of a big complex of buildings. Same, one building, but lots of different basements. And they said that the Abbott's
He added.
AVID, air, vapor, insulation and drainage.
Now, would you test like the ACH on that, or would you only like see vendors?
I'm sorry.
Would you test like the ACH on that? Would you only do like an ACH test then? Like an air change test, only the motor then? If you're only testing like that?
I don't speak in ACH, I speak in Pascal.
Well, no,
50.
well, no, because that's the same thing though, because you're talking about pressurizing home at cubic feet per minute. Why would you do an air change test of how much air change per that space is happening per hour?
Because ACH depends on the ratio of volume. Doesn't take into account the ratio of volume to surface area. So if you have a sphere, the ratio of volume to surface area is 1. If you have a snake coffin, a lot of railroad, the train, it's got a surface area that's a factor of order of magnitude more ratio from volume to surface area. And that's, so ECH doesn't help you, but CFM 50 per square foot of shell works on any shape. And you can compare air leakage from one to the other if you stick to surface area of shell.
Okay.
So ACH is what the code has, I understand totally why you say that,
Yeah.
but the code, the code is trying to change to a different unit of measure that is.
Yeah.
That works for any ratio of volume to surface area.
Now with like a pressure test, like a worst case scenario test on these spaces, help like seeing the ROI and something like that. Is it like a pressure test for certain call spaces? Or not?
I'm having a hard time hearing.
It's like a pressure test, like you would like see like,
Do a blower door test on.
yeah. Like what's the difference if you pressurize or pressurize? Like won't that come up the same thing?
No, there are 2 protocols for blower door testing,
Yeah.
pressure and depressure.
Yes.
If you do a depressurized test, you pull all the flappers on all of your fans shut. So then you get a good number, excluding the implication of leaky flapper. If you do a pressurized test, you blow them all open and you rip all the tape off the seams on your polyethylene, and then you make it work.
I've heard Seaberg said there's no difference, just if we're depressurizing in Ontario in the middle of winter, the job site's gonna be cold. So it's pressurized.
Yeah, but he's not talking about, I did a job in Virgins on the Shelburne Museum. And they did, no, it's a rectangular, it's the art storage facility that they built. And that building has a taped vapor retarder air barrier system. I did the blower door test on that. As soon as we turned the fan on, I shut it right off and I here's the tape unzipping.
Yeah.
Yes, because there was a space between the drywall and the plastic.
Forcing it.
It was ripping the seams open, so we did a pressure test. That pushed it against the surface. And that test we were able to finish, but. Think about what you're doing to the materials when you set up the rotor.
Can you speak to, there's context of modern form foundations, concrete foundations, but in the context of an old rubble foundation, an old historic home, from the perspective of a mason, in the health of that foundation wall, where it should really be before you go spraying foam on it. And we talked about embedding the plastic into spray foam to connect the vapor barrier to thermal barrier, but is there any scenario where
We were connecting the air barrier to the and the other air barrier.
fair enough. Is there any scenario where you want to leave some of that rubble foundation exposed and terminate your 15 mil poly above your high water?
If it's a chimney or fireplace space, definitely.
Or columns coming up,
It depends on if you're trying to dry, depends on whether you're trying to dry or protect from wet. That's the.
yeah, I'm just picturing a mason. Don't wrap my foundation. You gotta let this thing breathe.
There's no reason stone has to breathe that I know.
And where should we be from? Okay, we get everything repointed, get it all healthy and clean and free of debris, and then spray it or prime it and spray it. Versus, there's big open joints, it's using spray foam to act as mortar.
We always required anyone with a foundation, rubble foundation, to make sure it was structurally sound. And that means pointing is required. If it was really falling down, we didn't want to be in there anyway. Of course.
Yeah,
I think it's a common sense question in terms of, when does it make sense to put the structure at risk?
yeah.
And you don't want to have a callback because the foundation fell down behind your front.
Yeah, high variability. Definitely the rubble stone foundation where you want to.
Yeah.
In Vermont, rubble stone foundations, a lot of shale type small stones. And I have some big flat stones, but behind it's all small rubble, whatever. On this side of the river, you might have, car size chunks of granite.
Those aren't going anywhere.
Right, they're not gonna move.
Yeah. So,
The foundations are very different depending on what they're made out of.
So which one would you rather plaster or spray?
Not with the granite.
Yeah.
Is there a significant difference in labor costs for Avid versus?
The membrane from 1 foot below grade down is much less expensive than spray foam.
How do you attach it?
And sorry, it will be undone.
Yeah, that's a good point. Yeah. What we did was we took nails and nailed up the membrane before we started spraying into the cracks in the stones. Or we laid the plastic along the floor at the base of the wall. And the installer, he would hold it up and tack it with the spray foam as he went.
Okay.
We would glue it in place.
Find the right installer.
Doesn't take long to learn, but
You do the 2 corners, fill the middle.
yeah, we did a lot of them. So
Yeah.
they learned.
Techniques.
This is just, I know how much time do we have?
6:25 right now, so we're trying to wrap around 6:30, but we're having fun. So if you do have to leave, go ahead. Thanks.
Okay,
Wait, on the way out.
so a couple of quick ones I want to cover. This is ICFs, insulated concrete forms. That are on a foundation. This is rigid foam board and this is Thermax, so it's fire rated. We don't have to put a coating on that.
I'm not last time we take the top of the ICM.
That's foil tape. Just to make it look pretty. That's not for fire protection. That was BB. This is actually my basement. In one of my buildings. And this is a rubble foundation. And we were actually having, the problem here was we were getting silt coming in every spring when the water off the roof. And this would be, you know, there would be a lot of water. I put the ICFs in half, braced them into place with counterforts, and injected foam behind the ICFs between the rubble wall and the ICFs.
Why didn't you just spray foam them? Why go?
Yeah, after I was a spray foam contractor.
All right, thank you.
And
Thank you.
I had all these ICFs because we put that, we poured concrete in one of our
So
foundations.
that's not an actual application that you recommend.
But it's a possibility.
If you have a bunch of ICM sticking around.
It was, we could have put concrete behind this
Yeah.
before we, and I did it with foam because I had lots of paint. This is rigid foam board on a poured concrete wall. And that is a rigid foam board product that is rated for exposed applications. So it didn't have to be fire protected after the fact. One thing that a lot of spray foam guys do wrong is they insulate right around the pipes and then they freeze. They always want the pipes on the warm side of the insulation. This is backdrafting. Whenever you do any kind of air sealing work, you always want to check for CADs for backdrafting and so you don't have carbon monoxide. And I've seen furnaces that were backdrafted and started the whole furnace on fire. She did one house where they actually backdrafted the furnace while they were spraying by ventilating the space per the code recommendations. But they didn't check for CADs first and then burned the house down. So that's one way to get out of doing a spray foam job.
Yeah, get paid for it.
So the other thing, so this is install the air supplies to the combustion appliances, reduce the old units, seal combustion, high performance. Now this is the fire protection. This is the last slide. Foam in the attics and crawl spaces require fire protection. Any occupied space requires fire protection with foam plastic. AC 377 is an exception to the code if the foam is tested by NFPA, the National Fire Protection Association, and meets certain criteria. But AC 377 is not part of the code. It requires authority having jurisdiction approval. So you have to have your code official approve that. So if a foam installer comes to you and says, my product is AC 377 approved, you have to say, send me the literature from the code jurisdiction that approves that use. Because if that building burned down, the code official would be at risk in this case, and they're always trying to protect themselves. So anyway, AC 377 requires code approval. Written authority having
Per instance, per project.
per project. Yeah, this was that one. You can't. The manufacturer can't say, "Well, we got approval on one job." That doesn't mean it applies to every job. It's per jurisdiction. If you get approval from one code official, and you did another job next door in the same jurisdiction, it's not going to be okay. No, it's per project. It's per jurisdiction. Okay, you can't have multiple crawl spaces that are interconnected. So if you can fall through a rat hole from one crawl space to the other, you can't do that because the fire can spread through the crawl space. Like in that. ducts must be air sealed so that they can't leak and the fire can't spread through the ductwork. And don't use your crawl space as a source of induction air for your gas furnace or whatever. You want to run an insulated duct through the crawl space or basement to the appliance, so you're not just leaving the doors, the windows and doors open to the crawl space in the basement. And that's it.
Great reason in the same age with new construction, to have window wells. I mean, why not just leave them out and leave all the things so that window well out as well?
Was there any great reason to have basements?
Yeah.
Or crawl space?
I lived in my basement for 5 years while I was refinished the house.
There you go.
Well, I mean, the. Sorry, no, it's question. Just, I mean, I like the model of the envelopes just wrapping under the building and being up on stilts. It appears and being open in the basement to contain that,
How do you get the plumbing down to the ground?
and with the smallest basement. Yeah,
The small basement.
least amount of concrete.
Yeah,
I think tradition is good because of frost action, that's why we
Yeah.
have basically.
we have a 4-foot crossway.
Right.
Right, you know,
We
probably.
did this one, we did this one.
Yeah.
We didn't have means in precast periods.
Yeah,
Call for it up there.
The other thing about window wells, I've used window wells for exhaust fans, so like from a bathroom.
right.
Instead of having them come out to the top.
I was traumatized by
Some new stuff.
in 1977 flood in Kansas City. I was running around a bucket bailing them out, you know, it's a large house, but as the glass was pushing in inch by inch. They're filling up, but it seems to me that there are more households that work.
Oh, yeah.
I think in the past, they
People
would.
are looking.
For better.
Yeah.
You did well.
Get the cold and the cold.
You even figured out if it's your drawing.
But today was even like, skylight, like the system and.